Greetings. Welcome again to ME1003. I believe you've already met Katie. I'm Don Lyon. I'm a professor of mechanical engineering here. Starting my 30th year. Came here in 1991, so it's been a while. Uh, so, with respect to what I'm going to be doing, I'm going to be working with you on this side of drawing. Uh, and so, what's the historical purpose of this course? If we were to go back, uh, 30, 40 years ago, it was not unusual for students to come here or other engineering schools with 3 years of technical drawing when they came. Uh, and then, so the purpose of a course like this was for those that didn't have that experience to get them up to speed, because drawing was a critical part of how the program was brought out. When I went to Purdue University, started in 1980, graduated in 1984, just as dinosaurs went into extinction. When I was there, the first year, they had a large room that was a drafting lab. And so, much the way you would go to a computer lab now to use the computer and do whatever you're going to do, they had rooms, or in mechanical engineering, had a large room with just piles of drafting tables where students could come and do the drawings they needed to for their various projects, classes, etc., etc., etc. So, learning to draw was a really important part. As I said, people would come with up to 3 years of experience, and in fact, when I got to school, I was one of them. I had 3 years of technical drawing. I really enjoyed it, with the exception of one thing. The first year, we used to have all of these assignments just learning how to do lettering. So you had to do everything in block lettering, and the goal was to make it look like it was done by a typewriter. And it was arduous. And I actually had quite a bit of time working at an engineering firm. I'll get into that in a little bit. But your supervisors were always concerned that as you made your block letters, that they were all perfectly vertical, no slant, forward, backward. It was a pain in the neck. Anyway, so if you were to go back to even back just to the 1980s, if you were to go to an engineering office, you would have large rooms. So I worked at my father's engineering firm, starting in the summer of my sophomore year of high school, and worked there all the way through my undergrad. And they had a room that had to be 3,000 square feet or more. Just wall-to-wall drafting tables with people standing at them, working away. Everything had to be drawn from scratch. You could have a drawing that you referenced, but you had to draw it again as you started a new project. Things that you couldn't just bring up an old object from a computer file, pop it into place, and be done with it. So it was really a challenge putting things together. So I try to imagine making a power plant and designing power plants and then looking to build them. That was part of my father's business. I'll mention this again. But imagine you have a meeting with your client and they want to change one thing. That probably affected 50 plus drawings. So you had to go back and change every single one of them to accommodate this one change. It's a very different world. And thankfully, the world has changed. In the early 80s, CAD started coming in. Purdue started having access to CAD back around 1981, which was notable because the drafting table lab disappeared. They no longer had that. I actually had, when I went there, that was the last year they had a first year drafting course. It shifted then into a first year CAD course. And these days, they don't necessarily do that because most of the kids coming in will have had CAD. So the world started changing prominently in the 80s as you had AutoCAD, which would be a computer-aided drawing, 2D type drawings, just like we did at the engineering firms back then. And over time, that software started to get a bit more sophisticated, and the first growth in sophistication was object-oriented CAD packages, and you started to see them. In fact, I have one, much more modern, but dealing with architecture. So when I say object-oriented, you would have things like a door. So it's pre-done, or you can write the code to put it into the system, and then you can just pull it up anytime you want, and it just automatically goes into a wall, and everything is just adjusted for you automatically. And so you don't have to do everything drawing it from scratch. You can basically add objects into the software that you can pull out anytime you want. So that was sort of the next step of sophistication, and that's sort of coming rapidly into the 80s. And then the next level of sophistication was solid modeling. Now, solid modeling has been around kind of as early as AutoCAD was, probably, but it required extraordinary computer power. So you only had that at the big aerospace firms had access to that, and as we got into the 90s, the computer power caught up, and so you started being able to have that on PCs and whatnot, and so solid modeling became was the next natural outgrowth past object-oriented 2D drawing. And so that started coming about, and solid modeling basically says you basically build in 3D everything. So you're assembling it, you have all the parts being done up, and as that evolved, solid modeling evolved. They got to where they started parameterizing the solid models. So everything you design, you would be basically seeing it in 3D on your screen. But when they parameterized it, what it meant is that every aspect, or as many aspects as you wanted in the drawing, had equations tied to them. And so what that enabled you to do is when one part changed and it interrelated to other parts through these equations, they could all change automatically. And also you could have a part with all the various equations, and you could actually grab it, grab onto the corner or something and stretch it out, and as you did, all the equations would change with it. Incredible sophistication that's available today. And of course, it's the perfect tool to send over to a 3D printer. So that's the modern world we live in. Now, a little bit of my background. As I mentioned, I came to engineering. I had started working for an engineering firm, my father's firm. They did two things prominently. They designed and built power plants. And they also did mass transit electrification systems. So they worked extensively on the Chicago elevated train system. If you've been to Chicago, they've done a lot of work with that in the early days. Still do. They also did an enormous amount of work for the city of Boston for their subway system, and may still be doing that for all I know. So as I said, I started there as the summer of my sophomore year. I basically had two roles there. I was a junior draftsman, and I was a gopher. The nice thing about being a gopher is I got to travel around Chicago in the summer, and it was a fun place to be. Every so often, you could kind of blow the afternoon off and go watch a Cubs game. So that was kind of cool. So in terms of my own practice, I started using AutoCAD in the 90s for a variety of things. And in fact, curiously, I'll just go back to, I said I had 3 years of drawing experience. I had 2 years of architectural drawing experience before I started school. And I actually considered becoming an architect. Why didn't I do that? My father one time when I was probably in about 9th, 10th grade, took me to the office in New York City with him. And normally, if he had to take me to the office when I was a little kid, there were very strict rules. I couldn't make any noise or bother anybody, but he had made arrangements, and he said every single engineer in the firm is prepared to talk to you. So you can go talk to them and get their takes as you're deciding what you want to do with your life. So I was thinking about being an engineer, an architect, whatever. So I went to their architects group, and the guy who ran the department, we were chatting about stuff, and I showed him samples of my work and other things. And anyway, he looked at me, and at one point he said, I want you to guess what is the number one profession represented amongst cab drivers in New York City. So this would have been about 1976-ish. And I looked at him and said, I suppose you're going to tell me architects. And he goes, yep. So he said, it's if you make it, you can do really well. But he said it's one of the hardest fields to break into. And he noted that I really liked designing houses. It was kind of my artistic release, amongst others. And he said, you realize if you get a mechanical engineering degree, in most places you can design and build your own home. And I was like, really? And he goes, yep. And that kind of locked in mechanical engineering. Now, my dad's a mechanical engineer, and I'll actually show you drawings later on of the house I live in. I designed it, and I was my own general contractor. So it's something to do. It's a useful little thing for the background. So anyway, as I said, I used AutoCAD in the 90s, and around 1998, I stopped using AutoCAD. Why? When I went to build my house, I first designed it on AutoCAD, down to the stick, and was trying to work with my wife on the design and stuff, and she would look at this little picture on a computer screen and goes, how can that ever grow to be a house? God love her, wonderful woman, could not visualize a thing on the screen. So it became apparent I needed to draw it on a large scale on the table at a 1/4 inch to a foot, so that she could try to relate to what we were designing and going to live in. So, and it wasn't soon after that I bought a object-oriented architectural software package, and so I stopped. I didn't need it for anything else, so I stopped using AutoCAD. And the world continued to move forward, and so I'm kind of far behind. What kind of drawings do I do today? Let me just tell you what my background is. Normally, you would have a prof in design be teaching in this course, and that's not me. The stuff that I do, I'm in commercialization, tech transfer, intellectual property development and strategy, venture capital, seed capital, angel capital, or angel finance. This is not my normal bailiwick of things that I would do. So I do drawings, but I actually I can do everything I ever need to do in the drawing components of Microsoft Word, and I do that for patents. I do a lot of patent work. So one might want to ask, why am I here? Well, a couple of reasons. Because of the COVID situation, we had 2 professors who basically said, I can't do this. So they retired suddenly. It was unexpected. So, and I think we either have 2 or 3 professors out right now on sabbatical. So the mechanical engineering department is just suffering of a lack of resources. So it's all hands on deck. So sorry, you got me. So the other aspect is that there's been a major reallocation of resources within the faculty. This used to be covered by a stipend and various other things. I'm not going to go into that. That no longer exists. And then the other reason why I was brought in here, you will normally, hopefully all of you will continue with the program. You'll see me in the winter term teaching Engineering 1082, mechanics, which is part of my normal technical expertise. And I'm known as being a very student-oriented practical professor. when I say that, note I don't have graduate students. My research program is working with companies in the province, also finance people to develop technology, get it out on the market, finance it, et cetera, et cetera, et cetera. So I'm not your normal research prof that you get here. I'm much more into the teaching side, working with the students. So given the insanity that COVID is, and I know you all understand that, that's why I'm here. So historically, done a lot of drawing. We're going to be moving using a thing called Fusion 360, and I just got permission to download it from AutoCAD. So I'm going to be blunt with you. Many of you probably have your own 3D printers. So you're going to know more than me when it comes to that software. So this is going to be kind of interesting. Basic drawing, if I have to draw by hand and use machines and tools from the old days, I can do that. Not terribly useful, but I can do it. So this brings up the next question. What is this about? Okay, so what we want to accomplish here are three things. So as many of you coming to school, you've never had a technical drawing course, and you have no idea how that really helps wire neurons together. So as a result of that, many of you are coming in here with very weak visualization skills. We're going to address that. By the end of this class, you should have a lot stronger visualization skills. Students with poor visualization skills will look at what a prof is drawing on a board or whatnot, and they'll go, I can't understand this. We want to fix that, help you out there. Secondly, drawing is a very basic form of communication. You need to be able to just understand what it takes to communicate information through a drawing, whether you do it in the world of computer or by hand. Doing it by computer makes things easier. You just have to learn the culture of the software and do it. Okay, but the same principles apply by hand, and many times you're going to have to sketch stuff in the real world or just draw something by hand, and just having an ability to do that will help you as you're working with other software, as you're working with other people, etc. So the third thing then is we want you to also give you an idea of some of the standards that are associated with drawing. So those are the three core things we want to, and there's a fourth thing. As you go through this semester, what are you going to be going through? For those of you who are on campus, first of all, you got the COVID nonsense. Can't even imagine what that's like. But in a normal semester, students have a lot just to get used to the university environment. That's a big adjustment. Okay, so you have that. The other thing that you're dealing with is more math and physics than you've ever wanted to deal with in your life. And that's going to be really intense. And you're going to get through it. You'll handle it. Lots of people have. Given all the other serious stuff you're going through, a major purpose of this course is we're going to try to have a little fun. All right? And some of the things we draw and take a look at, hopefully we can make it more enjoyable for you. So this is a course where it's okay to have a little fun. And so that's what we'll do. So that's the end of this first video related to my first lecture here. I'm going to cut it off right here, and we'll reset here in just a moment. So please go to when you take a break, when you're ready, come back, and we'll talk a little further. Bye now.